one more example of radioactive calculations and carbon dating. What is the expected activity of a piece of lumber that is 4,000 years old? Now for this one, we're still going to use the same 15.2 disintegrations per second for live wood. That's not always the case because the number of disintegrations is going to be based on the meter that you're using to determine those. If it's tuned up a little bit more tightly, it might be 20 disintegrations per second that it measures, okay? Depending on how well it collects material. This is just a measure of, for this piece of equipment, how many disintegrations per second. Now if we shoot it at this thing that's 4,000 years old, what should be the number of disintegrations per second that it sees? That's the activity. So the natural log of n over n0 equals minus kt. And we already figured out in the last problem that k is equal to 1.21 times 10 to the minus 4th per year. We know that t is 4,000 years. We know that n0 is 15.2. So we're solving for n. So we have to split this term up. Natural log of n minus natural log of n0. That's how we split up a fraction. Equals minus kt. So then we're solving for n. So the natural log of n equals minus kt plus natural log of n0. So we can go ahead and plug in that stuff on the right. That's all the stuff that we know. So it's minus 1.21 times 10 to the minus 4th per year times 4,000 years plus natural log of n0 is 15.2. So we type those through. 1.21 times 10 to the minus 4th. Flip the overall sign on that. Minus 1.21 times 10 to the minus 4th times 4,000 plus 15.2 natural log equals, I get 2.237. That's not our answer. That's the natural log of the activity we're looking for. So n equals e to the power of 2.237. So that number that's on our screen, we hit second function natural log. So this piece of wood should show an activity of 9.37 disintegrations per second. So whatever activity unit you're given, keep it in that unit at the end. Disintegrations per second or just per second. Don't try to convert it into anything else, because if you make a mistake doing that, you can't do anything about that one. Okay? All right, thank you.